It's nice to meet everybody. I'm Kiran Devarakonda, the co-founder and CTO at Meibel. Meibel is a runtime platform for generative AI, and we're excited to be here to talk about structurable data. Let me share my screen, and I have some slides to share. There we go. And, cool. I hope everyone's able to see my screen. Um, Structurable data. That's the topic. That's the topic for the webinar today. As I said, I'm Kieran, the co-founder and CTO at Meibel. Meibel is a runtime platform for enterprises building effective generative AI solutions. And today, I'd like to talk about something that's becoming increasingly critical for enterprises, which is to leverage the hidden structure in their data for smarter retrieval and more effective generative AI outputs. Most organizations are sitting on a mountain of unstructured data, right? Uh, Unstructured in quotes, but at Maybell, we believe that this data is actually highly structurable and that the structure is key to moving beyond generic RAG systems. Right. So what I'd like to cover today is to explore the real world complexities of getting data ready for AI systems. It's messier, than most tutorials make it seem, and then we'll dive into why and how your retrieval method and how it impacts your outputs and the quality of the outputs that you're getting, and why throwing everything into a vector database is really not sufficient to get uh, to get the best fidelity and the best outputs from your data. And lastly, I'd like to cover how, combining a variety of techniques, vector databases being one of them, uh, will lead to more effective and robust solutions for your enterprise and organization. And finally, I'd like to show you how that manifests itself in a demo on the Meibel platform, and then take questions after that. So at Meibel, we believe that most unstructured data is generally structural, right? And this might seem like an obvious statement, or if you think about it, it strikes you as, as something that's clear. But what it's about is a, a shift in perspective in how you treat your enterprise data when preparing it for AI systems, right? And what we mean by that is um, there. I have a definition here. When we say structurable data, we're referencing the the structure that could be extracted from unstructured data, right? Um, Most unstructured information have rich patterns that can be leveraged to make your retrieval systems highly effective and much better than focusing solely on semantic relationships. It isn't just about getting um, say parsing tables from PDFs or things like that. Most unstructured data have rich hierarchies, relationships between entities in the documents themselves. That the sooner that you surface, the better the generative AI experience that you get. And let me step into what I mean by that. The different, if we were to look at the different sorts of documents that we have in enterprises, here the first example that we have might be say a novel, and this might not necessarily be an enterprise example, but there, prose has distinct relationships, characters, events, timelines, that if you were to simply match on semantic similarity, you would lose out on the rich uh, metadata that you would find by exploring the entities that is held within the documents themselves. embeddings themselves are only going to get you so far. The relationships and the augmented uh, representation of this information is really what's going to get you your scalable and accurate retrieval system. Similarly, if we were to look at product sheets, right? Here's an example of a product sheet that has embedded units and values and other structured information that when you choose to use it in aggregate could be highly valuable when looking at product sheets across your enterprise, right? Where you might want something that is the maximum of something or the minimum of something. These capabilities with a generic RAG system is hard to achieve without pre-computing these values to be able to represent it in the appropriate way for you to leverage it. Or if we were to look at legal contracts, for example, this legal contract has temporal information like times when the effective date, the parties that are bound by the agreement, of various entities that can be seen in a graph like relationship that is essential if you were going to work with a series of legal contracts, right? If you wanted to look at them in aggregate, you would need to look beyond semantic similarity and look at the information that binds these documents together. And lastly, if we were to look at something like the legal code, so we're from the state of Maryland, and we've looked at the Maryland legal code as an example, and certainly like most legal code, where looking simply at semantic similarities often not sufficient, right? So if you were to look at this document here, where it's a document on the statute of limitations, but it has provisional information that provides exceptions and additions, right? The statute of limitations is as follows, but it's also amended by another article of the legal code and multiple articles of legal code, in fact. And if you do not consider that in its totality, then you're not able to get a legal framework. What you get are legal fragments, but not necessarily the legal methodology with which to base an output or a decision or an answer. And even with structured data, um, it isn't that easy. For example, like if we were to look in this example where we have calls that are coming in, we have structured information in terms of the call ID and the call transcription, but in and of itself, it's not that useful without further enrichment, such as sentiment analysis, right? We couldn't just rely on the semantic nature of this information to provide us with detailed analysis or quality aggregate information that we can rely on to analyze the data. And so what we believe is that we from these sources of data that we can retrieve structured information, right? From that legal example, we can take the relationships between the passages and documents to create a map of those relationships to improve the retrieval that you're going to get, and to have multiple storage systems to really make this effective, right? Vector stores and similarity searches are but one tool in the arsenal for effective retrieval. In some cases, like in the product example, a relational database might be the most effective way to do it. While in the legal example, a graph DB might be the right way to represent that information. And in some cases, you want to use all tools available to you and use them simultaneously to provide the most robust context that you can muster for the LOL. With that, I'd like to step into a demo and show you some of these examples that I've been talking about. So let me jump into um, the Meibel console, and let's look through one of those examples. Right. So let's create a conversational agent over the Maryland legal code, like I was showing. So if we were to take the Maryland legal code and we were to ask that very question that we were looking at, and let's switch to a better model. Let's switch to Sonnet. And if we were to ask about what, you know, what is the statute of limitations uh, for misdemeanors, right, in the state of Maryland. And if you recall from the example that I showed you, the the statute is quite complex, right? Where there is a general rule, but it's amended and accepted a few times, right? It says 1 year is basically the statute of limitations, except for blah blah blah. And if you were to limit yourself strictly to a semantic query of that, you'd get a lot of information about statute of limitations, but you wouldn't be able to put the connections together, right? And what you see here is uh, is a comprehensive answer that, right, it says the general rule is 1 year, but we also have limitations and additions that indicate that that rule changes based on the scenario, and that scenario was discovered because of the structurable information that we discovered during the ingest, right? And so to look at it in a visual form, what has been done is that the top level here are the semantic matches of the legal code to provide this answer. But in order to provide a comprehensive answer, we really did have to walk down every relationship and passage uh, passage relationship that we discovered that was implicit in the legal code, but was absolutely necessary for us to uh, understand uh, understand the query and provide a comprehensive answer, right? Otherwise, we would have only matched everything that is to say about the statute of limitations, but we wouldn't have had any depth. We wouldn't have been able to provide the totality of the information that we needed to answer that question. And so this is one of the key aspects um, of structurable data, where uh, your basic RAG systems are going to fall down, because if you're not able to uh, comprehend the full context and help engineer the best context that you need, the LLM is not going to be able to provide the best answer that's needed for your situation. And now let me step into what about how we ought to process the data in order to be able to achieve outcomes such as these, right? So if we were to look at the data source itself, in this case, we've ingested the Maryland legal code, and what we've done as a part of that is we've broken down the references and the relationships during ingest, so that we're able to maximally optimize the retrieval, right? Um, through a robust ingest process that's able to identify all the structurable information within the data source, we're able to then get to a retrieval system that is able to generate the most comprehensive context. And so if you were to look at something like the legal code here, and we can look at a particular domain, right? So if we were to look at, say, finance, uh, it is an an immense jumble that if we do not look at it in its entirety, we are really going to provide anemic anemic and incomplete answers and outputs that is based on this data, right? So uh, yeah, that is the importance of structurable information and extracting structure even from your unstructured data, so that you're able to generate the most effective outputs possible. And this works in terms of unstructured data, but it certainly works as well with semi-structured data. Here we have the Steam Games recommendations, for example, where this information is ideally represented as uh, something that is queryable in a SQL sense. So if you were to look at the Steam Games recommendation, which is a public data set in Kaggle from the Steam Games platform, where they've got structured information as well that's combined with unstructured information, such as recommendations and reviews. And if you were to want to have um, a conversation with this data where you say, what is the most expensive game that is most positively reviewed, for example? Those would have to be pre-processed, and then that structure be extracted from the data set in order to be effective for those queries. Right. So let me pause there and head back to the slides here. Um, uh, Yeah, where and if you're working on something similar, if you have similar challenges, if this resonates with you, please do reach out to us. We'd love to talk to you, and if nothing more, just to learn from you and understand how you are dealing with some of these challenges that we see our customers face with their enterprise data.
Kiran, that's great. Thanks. Raise your hand. Go ahead, Lucinda. If I block off, Mike will pick up. Go ahead, Lucinda.
Yep. Hi. First of all, thanks for this. This is you're talking about something that I've just kind of been stumbling across for a long time, but you put it so well, and talked about like, okay, how can you extract structured data from unstructured? And so one of my questions was like, what when you're doing this, what order do you do it in? Because on the one hand, you may want to pull out like a table's worth of stuff. Other times you
Right.
may want to leave it more, with lots of information. So, like, can you talk, like a couple of layers deeper about
So
like what's going on there?
So when we look at a data source, right, we have machine learning models that are trying to identify all the different modalities of this particular data, right? And so the key philosophy is that there is no one right way to represent this information, right? And so uh, dense and sparse vectors are essential for those semantic queries, but we're also looking to see, is there implicit structure in this, such as references or other entity relationships that is graph-like. We're also looking to see, are there tables? Are there, what sort of media type is it? Is it a CSV? Is it inherently structural somehow? Can we leverage that and represent it in all of these different ways, so that when it comes to a query plan, that we're able to kind of look across the different modalities that a single data source might represent, and produce the most comprehensive sort of query capability, and then ultimately a response synthesis capability.
How do you extract the implicit structure? How? Like, how do you do that?
And so we have machine learning models that are looking to see if there's implicit structure, right? And so they are sampling your data source to look at and understand what sort of structure, are there references? Are there reference? And in some cases, it's quite simplistic, right? If it's a series of HTML documents, is it are there hrefs that we should be acknowledging? In other cases, are there patterns? In the legal code, for example, are there patterns that we should be recognizing as repeated across the corpus, right? And then finally, in cases where maybe it's not obvious to us, we have our customers guide us through the platform.
Okay. And then how do you have machine learning models do that? Because I don't think of that as a way to do that.
So, I mean, machine learning models, we use machine learning models for various purposes, right? So, like, for example, if we have a document that we need to OCR, we need to understand the reading order of the document. We need to understand, how to semantically to chunk the documents and so on. So we have machine learning models for a variety of such reasons that we use in the ingest process to help us with it. But as I said, like, we're going to do our best, but there are going to be cases when we'll need a source of truth from someone to help us.
Thank you.
That's great. Go ahead, Douglas.
I'm curious if you can use your tools to create structure out of one's existing website to enable, the answer engine to find your information.
Yeah, absolutely.
Yeah, that seems such a great use case. I'm like, damn.
Absolutely. So, like, hrefs, for example, are one of the,
Right.
they're one of the most essential and most direct ways to have an association between things. It's more complex in situations where it's not so, it's implicit in the content itself.
Sure.
But
Sure.
yeah.
Thank you. That's awesome.
That's great. Go ahead, Bob, and then we'll go with Katrina.
Hey, just the question's not well formed, but I'm sitting here wondering. I have a client who basically calls his data lake a data dump. Basically everything's in there. And is there a way to use your tools to basically clean it or standardize, or I don't know. Maybe that's above and beyond. That's not what you're trying to do. But I just
Right.
taking a
No, I do. That's a good question. Like, data cleaning is not necessarily what we do, right? So if that's something that needs to be done, I think that would be done a step before you get to our platform.
Right.
What we
What
would say
we
though,
do.
in that situation is, you can go through a never-ending cycle of trying to clean data, right? And I think we've been trying to clean data since data existed in the world, right?
Right.
We find the best use cases when a customer has a clear goal that they're trying to solve, getting the data that they think solves that goal into the system. The system will highlight what data is being useful and what data isn't being useful to the responses. And you can iterate it on it through that. But just taking, I don't know, a large data lake and saying, hey, make sense out of this. That's not really what we do. Maybe there's another company out there who's cracking that nut.
Somebody
but-
can make a shitload of money if they could figure that out. But
Right.
anyway.
Well, you probably make a shitload of money just ingesting the data, telling someone.
Yeah, I know.
But that's not really what we do. And sorry, I didn't introduce myself. Kevin McGrath,
No.
I'm the CEO of Meibel, but I just thought I'd jump in on that one. So
Thank you for that. Sorry.
That's great. Thanks, Bob. Go to Katrina, then Raymond. Go ahead, Katrina.
Hi, yeah, so my question was more along the lines of I if how much sort of like explanation do I have to give to your tool in order to create your figure out
Yeah.
you understand what I'm trying to say? Or do I just feed you all the information and then you can figure it out? I feel like to be effective, I need to give you more information. Correct?
Absolutely, yes. I mean, so that is a core philosophy, is that that AI human collaboration is really how we get the most effective solutions here. So what I'll say is that we're gonna do our best to figure it out, right? And we're working hard to look across the different use cases to understand commonality that we can apply. But just as you said, there's going to be a domain, there's going to be a use case where it's like, no, I know best. I want to tell you. And so the way we're designing the system is to give sensible defaults, give you an approach that we think fits, and then give you all the utilities and tools to help guide us and correct us as we go through that process, and make that very intuitive and not cumbersome for you to do.
Yeah, I think that makes a lot of sense. And then, so do you have any information on like, because I can see how this is like way better than just a, a generic rag, because of the chunky, all that kind
Right.
of issues. But um, in order to sell this to like a client or something, I'm wondering if you have like a one pager or something like that that says, okay, well, with
For sure.
generic rag, this, do you have that type of, I'm sure you do, right?
Absolutely. Yeah. We
Okay.
can reach out to you and get that
Okay,
information
cool.
to you.
Thank you. I'll send you an email.
Thanks, Katrina. Go ahead, Raymond.
Yeah, Karen, thank you. Thanks for the presentation. I was curious. So it sounds like you're using like a hybrid rag because you're using, dense and sparse, but then also it sounds like you're using like graph rag mixed in with that. And I was curious about what you're finding is the optimal chunking strategy.
It really depends on the use case, right? And so
Mhm.
there are in some cases the chunking is almost irrelevant because you might have a situation where the optimal representation of that is not in any semantic capability, right? What we actually need to do in order to make that data work for you is have an in memory SQL representation, for example. Um, so and even with chunking, it depends on the sort of data that you have, and this is where sort of the interactivity with the customer really comes into play. We're gonna take our best guess at what we think that means. But there are going to be cases where someone says, "Hey, semantic similarity is really the way I'm getting the best output here versus hierarchical." Where we break a document across by the sections and headers and so on, or an arbitrary sort of length of characters. Um, so the platform makes it really easy for you to try those different capabilities out and see what's really working for you. But it goes beyond chunking, though. That's my point. Where chunking is one important aspect of it, but there are all these other representations of your data that might be even more important for your optimal retrieval.
What might be some of those others? Like, because I mean, we know about graph, we know about semantic. What, and I know a lot of models are, we're multimodal now. So what
So
are some of the other that you're
So
aware of?
let's look at something like SQL, right? So if you want to have a question, let's say you have a series of CSVs that contain product information or order information, sales information, perhaps, and you'd like to have a qualitative answer over that set of quantitative information, right? You'd like to say, "Hey, give me the most expensive thing that was ordered." And the reviews for like grouped by the reviews, for example. uh, with RAG you inherently have a top K problem where if you want to look at a whole corpus of information and you want to say give me a breakdown of everything that's here, with traditional RAG you have to have some way to pre-compute that information in order to be able to do that. And LLMs aren't good at math either. So if where you need to use SQL, you need to use SQL, right? Where you need to use a graph algorithm, you need to use a graph algorithm. And that's the reality of effective generative AI is like, okay, I got this data in these different modalities. I need to query them appropriately in those existing structured mechanisms that are effective before I synthesize the response with an LLM.
That's great. Let's keep driving here. Go Ted, and then we'll go to Tim. Go ahead, Ted.
Hi, thanks. Yeah, I was just curious, like how you know your data is good and how you improve that over time through your system.
So one of the things that we do, and I showed you that a little bit, we highlight the data that was leveraged to produce an output, right? And that's key. Uh, you know, we call it practical user-facing explainability, right? So how is your data being used to generate the response. So like, let's talk about the Maryland legal code again, for example. Maryland legal code has been in the public domain for decades, right? And it's evolved over decades. In the use case that I want to create, I want it to use a particular version or the latest version, for example, and I want to know uh, if uh, if uh, if my outputs are leveraging my data or if it's potentially prior knowledge or hallucinations. So one, we highlight the actual documents that are being that are most entailed to the output that's produced, but we also have a secondary approach of providing a confidence score that also checks to see if the output tokens are actually present in the input, right? And to what degree, and so that you can then assess whether this is truly, is it my data that's the problem? Is it the model that's the problem? Like what's really generating the sort of outcomes that I'm getting?
Great, thanks.
That's great. Go ahead, Tim.
So this is interesting. I'm just trying to make sure I kind of understand. So it looks like well, let me just say what it looks like, and then you can tell me where I'm wrong. It looks like you're using LLMs mostly just to take the question in, maybe do a little parsing, and then emit the response in a structured format. But in between, you've got some sort of software architecture that has various kinds of tools that you've applied as you ingested the data that you can then apply as you query the data if needed. So you've taken a bunch of unstructured data, you put it through some transformations to create some structure around it, and then you can query that structure at runtime using various tools. So let me just start there. Is that even close to correct?
Yeah. And I mean, I think you basically got, we've got a sophisticated ingest mechanism that is trying to identify the right way to represent this information. And we use LLMs in that process, and we use other techniques in that process as well.
Okay, right. So you use general machine learning techniques and maybe even some other techniques, including LLMs and maybe topic recognition and NLP and image recognition and various kinds of things to create certain kinds of structure. You're looking for certain kinds of things because you're aware that there are URLs and CSV files and stuff that might be simple to recognize. And then you're creating let's call it a semi-structured representation. Then when somebody queries it, you may use some variety of tools against that structure in order to get the information they're asking for out. So how does that part work when somebody, like the question you asked about the statute of limitations, how does the system decide how to attack that query and which tools might be the most effective against this semi-structured database that you've created?
That's the whole startup, isn't it? Yeah. So yeah, I mean, so I'm joking about how that being our startup, but yeah, I mean, so what's happening under the hood is that we are creating a data catalog, right? And when a query comes in or when a request for an output comes in, that we're able to decompose that and then identify through referencing the data catalog and various other mechanisms as to how to best execute this user query and then synthesize the response.
Okay.
And so yeah, I'll just leave it at that. In a nutshell, that's really what's going on, is that we are
makes a lot of sense. Great, thanks.
Right. Thanks. Let's do 2 more questions. Go ahead, Alden, and do one after that. Ted, I think your hand's up, but I think that's from your earlier question. So we'll start with Alden.
Hi, Kiran. So this is fascinating, and as you can imagine, really important, especially for mixed type data, like these PDFs with complicated tables, images, and all sorts of reference and things like that. So in your system, after you've built the representation, which is JSON, and converted it into RAG or GraphRag or whatever. Are you maintaining all of that data, or do you pass it downstream to somebody else to solve the problem?
It's all ours.
All okay. So
It's
you handle everything from ingestion to the inference?
exactly right.
Okay. So you probably built a router or something like that where looking at based on the query, you send it to the right type of representation. Like if it's a NLQ query, you will send it
Right.
to NLQ and SQL. And if it's a
Right.
GraphRag type query, you'll send it to GraphRag.
Yeah, this is exactly what I was referencing with our data catalog approach, right? We try to decompose the query and ensure that we're servicing that query as best as possible with the different representations that we've identified during the ingest process.
Okay. Yeah. Okay. This is fascinating, and yeah, it'll be interesting to see like how it performs on benchmarks, and like
Sure.
even that would be a good marketing for you guys to do. Like just publish something to show how you'll smash everybody else on simple QA, or a mixed uh, data set like PubMed papers, for example. Those are like
Right.
insanely difficult to pass and query. So that would be good marketing.
Great. Thank you for the
Yes.
suggestion. Yep.
That's great. Lucinda, take us home. Yeah, you're on mute.
I'm going to ask Ted Vahey's question here in the chat. And it says that you really need a subject matter expert in order to understand the structure. Totally get that. In fact, that's how I found all of the applications I've worked with. Then the question is, do you have an SOP for extracting that knowledge from the SME? In other words, what I found is that you're trying to get the unspoken implicit rules and understanding of a business, right? Out of a document, out of the
Right.
language. So how do you do that for a specific use case when you're working with people?
So, let's. I think a practical example would be useful, right? So we're working with a managed IT services firm. They've got 200 locations across various countries. Uh, and what they do is they have technicians who solve IT problems. So their customers call in and say, "Oh, email isn't working," and so they'll go and reboot the email server, for example. And what they'd like to be able to do is have a question and answer with their 200 different databases that they have about who's the most efficient technician last week, or which customer was most likely to churn. Right? These are sorts of questions that they'd like to answer, and when looking at their data, right, we took an initial stab at it, but we got some of the answers wrong because efficiency to them means billing hours, for example, and all the billing hour columns in their CSV information is named BH, which we could in no way, that is not something that we could have discerned on our own, right? And so this was a case where we worked iteratively with them. Through our tool, they're able to provide those definitions and entity information, column information, descriptions that are essential for our tool to work, right? And I hope that answers your question. But there are going to be cases when your domain is difficult, or your data is in one way or another inscrutable, at which point we do have to work interactively through the tool to be able to define those definitions in order for the tool to be effective.
Yeah, I found that to be a very intensive process. I'm trying to figure out a way how to make it faster.
So not this isn't necessarily meant to be a sales pitch, but like that is what we're striving to do. Is we're trying to surface that information and make that iteration as quick as possible.
Thank you.
So thank you, everyone. Great presentation, Kiran. Really, really great. So thank you, and thanks, Kevin. So kudos. Last 10 minutes here is open mic. So if people have questions or unbelievable things, or if they want to share what they're doing on Banana Nano or Who's been blown away by something's happened in AI in the last 1 or 2 weeks? Anybody have any children's stories for kids going back to college or high school?
Hey, Paul, I've got a
I-
great story if you want.
Yeah, go ahead, Tim.
This is one, so this just blew my mind, both because of the sort of the empowerment was the big thing, and then the actual results. So this analyst at the firm I'm working with was asked to sort of do a meta-analysis for process improvement of time card narratives, so that people enter their time and they say, I was doing this and that. There are 150,000 of these entries, right, over a couple of years, large projects. So it's overwhelming in a big, huge spreadsheet. And she wants to know, well, how much of it was project management? How much of it was direct client work? How much was scheduling? She had like 10 different categories. And she's trying to figure out how to do this. So she asked ChatGPT. It does sort of a lousy job. But then she says, well, how do I do this? It's not working very well. It says, well, I could write a Python program for you that would help. And she says, what's Python? And it says, well, it's a programming language. So anyway, long story short, for those of you who are technical, she actually wrote her own model. So it didn't just write a little Python program to do some sorting. It told her how to create a machine learning model using PyTorch, which is the library from Python that makes machine learning models. So she literally made a customized machine learning model. It took her about 3 weeks, and there was a lot of back and forth, but she got it to work. And it taught her how to create a training data set and a validation data set-asides to get the thing right, and then to evaluate it through samples afterwards. And she got it up to about 85% accuracy on these 150,000 entries. And she was just so excited because she was like, I could never have believed I could have done something like this. And, she did it like a true data scientist. And so that to me was the most amazing thing. It was amazing that she got it done at all. It was just unbelievable and a nice little thing to get done. But it was really amazing how empowered she felt. So it's just one of the nicest conversations I've had in a couple of years.
That's fantastic. What a great story. Thank you. Lucinda,
I had a question for people. So I'm going to be doing a session on evals in 2 weeks. And so I'm really interested in knowing what you want to know about evals. Like, or you want to know what they are, or like how to use them, or an example, or like, because the issue with language is that the output is a language. It's not like something like a number that you can check, right? So how do you know if something's good? And if you change your prompts, how do you know if the answers that you're getting are better or more accurate? So yeah, I'm interested in hearing what people would like to hear about evals.
All the above. Yes.
Okay.
And the practical management of it. How do you deal with changing prompts and changing models and making sure that your answers are still as good as you thought they were at the start? And how do you generate those evaluation things? The whole 9 yards, I think, is a black art for most organizations.
I think it's almost a black art that only a few people kind of realize, like, oh shoot, I really got to do this,
Lucinda, jump up a level for the 101 folks in the audience. What exactly is an eval, and why should anybody care about it?
Yeah. Okay. So we're doing a project right now, and so we've built the code for it. So and then like normally you would do unit tests to see like is your code working and turning out the right numbers, etc. But the thing is now you've got this layer of stuff that's also coming out that's language. And so when you read, like an output from a chatbot or an output, language output from a process that you're doing, and you say, that's kind of off. That's not quite right. Or, it's trying to explain stuff that I actually don't care about or whatever. And so it becomes so kind of fuzzy and subjective, but like, how do you attach some numbers to that? And so I took this course and I've been reading this guy, Hamel Hussein, and his blogs. I'll put a link on it here. But basically what he does is he says, you just have to go through, you read the answers that you're getting, right? Do like 100 of them. And then you say, is this satisfactory or unsatisfactory? So you're not doing a 1 to 9 scale. You're just doing pass or fail. Then for the ones that are failing, you say, you know, this one, it didn't, it paid attention, it caught an error here where there didn't exist one, and it did another one that it missed another one. This one, it's worded in a rude manner, or, you know, too casual for the context, etc. And so you start having to do these judgments, and then you create a bunch of error modes. And then whenever you change your prompt, now you can like run a bunch through, and you can see like, oh, for tone, we used to have 17 out of 100 that would be the wrong tone. Now we have 9 out of 100 that are the wrong tone. So it's just in a way to kind of start attaching numbers and characterizing failure modes and doing an error analysis on all these outputs. And you need a subject matter expert to give you guidance, or at least like transfer the knowledge into you as you're writing this stuff, so that you can make the judgments. And then eventually, if it's really hard, then you do make an LLM judge for it, and so that you can automate doing a lot of them and really fine tune the iteration. But the question is, you know, how do you take all these like word outputs and change it from that into doing a prompt? You can do a lot in your brain, and just as you're like, oh, that's wrong, I'm going to change the prompt. But then at a certain point, you get to the more kind of mechanical and kind of fine-grained part where you're trying to get from 85 to 95 to 99%.
It's really great. Well, Lucinda, we're super excited for your presentation in a couple of weeks. Let's end on that. So Kevin and Kiran, thank you for a great presentation, and everyone, let's keep the learning going.